Hey, it's Mr. Estrada here, and our learning target for this video says I can identify tangents and apply the tangent-secant theorem. So a tangent line is a straight line that touches a curve or curved surface at a point, but if extended does not cross it at that point. So let's take a curved surface or circle, and let's draw a tangent. There it is. Meets our definition, right? A tangent is supposed to touch the circle or the curve at a point. We call that the point of tangency. So this is called the point of tangency. Point of tangency. And even if you extend it to the left or to the right, it will only touch the circle at one point. Let me draw another tangent. There is another tangent. Touches the circle at one point. Now this here is not a tangent. So this is not a tangent. Because if you were to extend this line, it would touch the circle at 2 points. So that's the key, right? It could only touch the circle at 1 point, even if you extend it. The tangent-secant theorem says the tangent squared equals the external secant times the whole secant. When it says tangent, it is referring to the segment that goes from this point to the point of tangency. The external secant, as you know from our previous video, is the part of the secant that's outside of the circle, and then your whole secant is the external secant plus the inner secant, we'll call it. So that's the whole secant. The external secant plus the inner secant gives you the whole secant. And the tangent-secant theorem, again, it says the tangent squared equals the external secant times the whole secant. Okay, let's work some out. Example 1, solve for z round to the nearest tenth. So this z here is our tangent. This 8 is the external secant. And our whole secant is going to be 16 plus 8, which is 24. So here's our formula. Whoops, that's not our formula. That's the substitution. There is our formula. It says t squared equals es times ws. So the tangent is z, so we get z to the second power equals the external secant is 8, so 8 goes there, and the whole secant is 24, so 24 goes there. So we get z squared equals 8 times 24, which is 192. Now we got to solve for z, so we square root both sides, and we will get approximately 13.8564. We are told here to round to the nearest tenth, so our final answer is 13.9. Example 2. In the accompanying diagram, PC is tangent to circle O, PBA is a secant. PC equals 6, so let's go ahead and label that 6. And PB is 3, so we'll label that 3. Find AB, so we will label that X. And then it says find PA, so we'll worry about PA later. We got to find X first, so let's just worry about how we're going to find that X. So that 6 represents the tangent. That 3 represents the external secant. So this is the external secant. The whole secant is going to be the inner secant plus the outer secant. So that's going to be x plus 3. And remember, I said that 6 is the tangent. So we will substitute, and we will get the tangent squared, which is going to be 6. So 6 squared equals the external secant, that's 3, times the whole secant, x plus 3. 6 squared is 36. We got to distribute the 3 here, so we get 3x plus 9. Subtract 9 from both sides. 36 take away 9 is 27 equals 3x. Divide both sides by 3. So we get 9 equals x. So if 9 equals x, that means AB is 9. So we can say AB is equal to 9. Now, PA is the sum of that 9 and 3, okay? You're not going to multiply it to get PA. A lot of kids confuse that for some reason. To get PA, you have to add AB and BP. And that's just going to be 9 plus 3, which is 12. So PA is equal to 12. So that is our final answer. All right, I hope this video helps you. Have a good one.